In this video, we are going to revise some grade 11 trigonometry. So just a reminder that trigonometry is the branch of mathematics dealing with the relations of sides and angles in a triangle and with the relevant functions of any angles. Okay, so just a reminder about the three trig functions that we deal with at school level. Those are sine, cos, and tan. And sine is always opposite over hypotenuse. Cos is always adjacent over hypotenuse. And tan is always opposite over adjacent. And that gives us the acronym SOHCAHTOA, which will help you remember. Then we have the trig functions on the Cartesian plane. This is where we change from referring to the trig functions as relative to opposite, adjacent, or hypotenuse. We change it to be in terms of y, x, or r. Okay, so looking at the triangle that we can form on a Cartesian plane, r is your radius, x would be your x value, and your y value. Okay, so sine is y over r, cos is x over r, and tan is y over x. A reminder about the cast diagram, which helps us to see in which quadrants the trig ratios are positive. Just a reminder that the axes split the plane into 4 quadrants: quadrant 1, 2, 3, and 4. In quadrant 1, all trig functions are positive. In quadrant 2, only sine is positive. Quadrant 3, only tan is positive. Quadrant 4, only cos is positive. Right, let's look at some typical examples of a ratio of a trig function in terms of a variable. So we are told here that if tan 29 degrees is equal to m, determine cos 29 degrees and then sine 29 degrees. Okay, so what we see here, we have a trig function in terms of a variable m, and looking at the questions, I notice that the angles are the same, but our trig functions are all different. Now what you can do is realize that tan 29 is equal to a ratio. Now m can be written as a fraction as m over 1, and we know that tan is always opposite over hypotenuse. Okay, so if I were to draw a triangle, okay, and this is my angle, 29 degrees. It's a lot more than 29 degrees, but it's not drawn to scale. Okay. Then the side opposite my angle is going to be m. And the hypotenuse, sorry, tan is not hypotenuse. It's opposite over adjacent. Sorry. So the adjacent side will be 1. Now I can find the hypotenuse using Pythagoras. So Pythagoras says that the hypotenuse squared is equal to the sum of the squares of the other two sides. So that is m squared plus 1 squared, which is 1. Okay, so to find the hypotenuse, I square root, and that gives me the square root of m squared plus 1 squared, which is just 1. So the length here is m squared plus 1. Now by forming this triangle, I have all 3 sides, and I'm then able to answer these questions in terms of m. So cos 29 degrees, cos is adjacent over hypotenuse, so that gives me 1 over the square root of m squared plus 1. For b, I have sine of 29 degrees, and sine is always opposite over the hypotenuse. Now the side opposite the 29 degrees is m, and our hypotenuse is m squared plus 1. Right, Pythagorean problems, because they use Pythagoras. Okay, so a more complex example here. If 17 cos theta equals -8, and theta is an element of the domain 180 degrees to 360 degrees, calculate without the use of a calculator and with the aid of a diagram the value of 8 tan theta minus 17 sine theta. Okay, The important thing here is that you are not allowed to use a calculator and you have to use a diagram. Okay, so what I have in the corner here are the steps that you would typically follow. The first thing you need to do is use the given information to decide in which quadrant the angle lies. Okay, so if we look at the information given, this is the information given. Okay, we have 17 cos theta equals -8. Now I'm going to use that to determine a sign for cos, because I can apply to the cos diagram. So if I solve for cos theta, I'm going to divide by 17 and I get -8 over 17. So this applies to a quadrant where cos is negative. Okay, so if I just quickly draw the quadrants, cos is negative in the second quadrant and the third quadrant. Okay, then I'm also told that theta lies within the domain 180 degrees to 360 degrees. Okay, so if this is 0, 90, 180, 270, back to 360 degrees, 180 to 360 is quadrant 3 and quadrant 4. Now those two bits of information overlap in the third quadrant, so my angle in this case is going to be in the third quadrant. That means I draw a line in the third quadrant. My angle will be, sorry, this should be at the origin. My angle, let me try to do that better. Okay, so from the origin, my angle extends to the third quadrant. Okay, I then draw a vertical line to the x-axis to close that triangle. Okay, now this is going to be my hypotenuse. My hypotenuse is always r. Then the vertical line is my y value, and I need to remember that in the third quadrant y is a negative value because I'm below the x-axis, and the horizontal side of the triangle is my x value, and again I'm to the left of the y-axis, so x is going to be negative. Okay, now from my cos theta equals -8 over 17 equation here, I know that cos in terms of the Cartesian plane x, y, and r values is x over r. Now r is always positive. Okay, so I know that r is 17. That means that this negative must apply to my x. And I have that x is -8. Okay, now to find y, I would use Pythagoras. So y is not the hypotenuse, it's the side. So the side squared is going to be the hypotenuse squared minus the other side. Okay, so let's substitute our values in there. R squared is 17 squared minus x squared, which is -8 squared. Now, this is where you are allowed to use your calculator. Okay, the point of not using a calculator is not for this bit. It's for you to really be using the diagrams and not just putting the values into your calculator. Okay, so 17 squared minus -8 squared, you would work out to be 225. Okay, and the square root of y squared, okay, remember we always get two values, plus or minus. The square root of 225 is 15. Now you need to decide, do I take the positive or the negative value? Okay, in the third quadrant, y is going to be negative. So I want, but y is negative, so I have y equals -15. Right, I have the x, y, and r. So let's go back to the steps. Draw a cast diagram. I've got that. Fill in the known values with the correct sign. We did that for the x and the r. Find the missing value using Pythagoras' theorem, which we did to find y. And finally, answer the question, which was to find the value of 8 tan theta minus 17 sine theta. Right, so tan theta is y over x. Now my y value is -15, my x value is -8, minus 17 Sine theta is y over r, so that's negative 15 over 17. Okay, now to find these values, it's quite easy without a calculator because my 8 and my 8 cancel, 17 and 17 cancel, so I'm left with negative 15 divided by negative, so that's positive 15. Negative times negative 15 is positive 15, so plus 15 again. That gives me a value of 30.